Hello and welcome to R&D Mathematics. Today we are going to talk about logarithmic function. In our last video we introduced log. Now for x greater than 0, and we'll see why in a minute, and b greater than 0 and b can't be 1, log function is defined by f of x equal log base bx. Now, if you can remember, now let me recall. Exponential function f of x equal base b to the x. If the base is between 0 and 1, and exponential function f of x equals same thing, b to the x, but if b is greater than 1. Can you guys remember the two shapes of graphs? So this guy, it looked like this. It went through this point 0, 1. And this guy looked like the other way around, 0, 1. Now at this point, I would like to make this comment. Log and exponential functions are actually inverse of each other. Inverse of each other. Because it comes from the definition. We will see this when we do more log properties in a future video, but for the time being, and we know inverse function and a function, if we draw the graph, they are symmetric around y equals x line. So in other words, the graph of, now let me use red color for, let's say, f of x equal log base bx, and here also f of x equal log base bx. That graph should be mirror image of the blue color graph around about y equal x, that white color line. Now how do you mirror image it? Now let me use yellow color. For this one, the one in the right hand side, it's easy. This point will be the mirror imaging point of that one, 1, 0. And see, this will look like this. And the blue color one here is its limiting to x-axis right here, and the yellow color one similarly limiting to y-axis, because that's what will happen when you mirror image it. And for this guy, one easy way of mirror imaging is to think about breaking it into parts. For example, this will, if you think about, first let me draw. If you think about this part over here, mirror image of that will look like this, right? And then the other remaining part, I mean this portion of your graph, mirror image about y equals x-axis will look like this. See, that's an easy way of, so it will look like this. So that's the graph of log functions. And with this one, there are a few things to note here. Domain, both of them domain, let me write down in the middle because it's common. Domain, as you can see, 0 to infinity. So remember this, log function domain must be 0 to infinity. That means the thing that you put here, it has to be greater than, it has to be strictly greater than 0. It cannot be 0, it has to be a positive thing. And the range, again, both of them, if you project it down to y-axis, see, it covers all the possible y values, so negative infinity to infinity. And x-intercepts, see this point again 1 comma 0 and here 1 comma 0, so x-intercept for both of them 1 comma 0, and then y-intercept, you don't have any y-intercept, so y-intercept none, because the domain is positive, it will never cross y-axis. They all have the all of these things are same, but still we have two different graphs. Those are things to note. Now, with this being said, we can start, finding domain of log functions. Now, this is really easy. Let's see an example. So what you need to do is this. So let's say f of x equal log base 2x minus 5. Now, when you want to find the domain of a log function, actually base does not do anything special. What you simply need to do, take this part, the argument, and make it, we must have that part 2x minus 5, that must be positive, and then simplify it. So 2x greater than 5x, 5 over 2 in a number line, 5 over 2 to that side, or in an interval notation, 5 over 2 to infinity. That's the domain, simple as that. Let's see another example. How about f of x equal log base 3 for minus x. So the domain, so d of f, to find this, what you need to do, take that, make it greater than 0. So minus x greater than, when I subtract 4, minus 4. When I divide by minus sign, in inequality sign change, so x has to be less than 4. So negative infinity to 4. That's the domain. And let's see about this example. F of x equal ln x squared minus 9. By the way, ln means it's a special notation for log base e. And I'll talk about this later. And also log, we just use log for log base 10. So these are two special notations. And I'll talk about that in a future video. But for the time being, this simply means log base e x squared minus 9. But again, what you need to do to find domain of f, you just take this guy and make it greater than 0. Now that means I see factors x minus 3, x plus 3 greater than equal to 0. Now this is not like last examples. You have to draw the number line, and 3 is a special place because when you 3 and negative 3, when x value is 3 or negative 3, your argument is 0. So it cannot be. Now we need to check these portions. See, these two numbers will break your number line into 3 portions. Now let's check each portion. Pick your favorite number. Let's say x equal negative 4 in this region. And if I put into this one, so x squared, 16 minus 9, positive, yes. So this region is valid. And this region, x equals 0. 0 squared minus 9, positive, no, that's wrong. So not this region, and sure this is going to be the case, but let's check x equal 5. 5 squared minus 9, that's 25 minus 9. Yes, that's true. So our domain is going to be negative infinity all the way up to negative 3, union 3 to infinity, without that middle part. Okay, one more example. Let's say, how about, what if you had g of x equal log, that means log base 10. If I don't put anything, I will talk about that again in a different video, but for the time being, to find the domain, you just need to take your argument right here and make it greater than equal to 0. Now, how do you solve this? You have to remember something. We know any absolute value. We know this must be greater than or equals to 0 in general, right? That's always the case. But in this particular, when we need to find the domain for log function, we must have greater than here, not greater than or equals to. So everything except that value 3. Does that make sense? If it doesn't, see, plug any number for x you want, any number x equal, if you put a negative number, negative 100. Negative 100 minus 3, that's negative 103. But still, when you get the absolute value, that's positive. So yes, it's positive. It's always positive, except for x equal 3, it will give you 0. But 0 is not allowed for a log function. So everything except 0. So the domain of f is negative infinity to 3 union 3 to infinity. Or all real numbers minus this one value. These are different ways of writing down domains. Okay guys, I think that's enough for this video. So simply when you have log function, whatever you have here, take that, write down it again and make it greater than 0 and solve it. Simple as that. Okay, thank you.